Great perspectives on huge importance of data standardization for AI. Thank you, John. Now let's hear from Dominic Gallello, CEO of Symphony Industrial AI. Over to you, Dominic.
It's a delight to be able to talk to you today. My topics, I'll give you a quick introduction to the company and really this whole topic of scaling AI with some use cases. In terms of our company, Symphony AI is a group of companies really focused on vertical applications such as retail, media, and the company that I run, Symphony Industrial AI, is focused on everything delivering automation in the industrial space. Our divisions, digital manufacturing, this is connecting devices, processes, people, and applications, connecting from level 1 to level 4, and really in batch operations, taking variability out of process. Our customers are some of the largest companies in the world, doing a huge amount of automation, connecting sensors to workflows, to really driving to closed loop driving of the machinery that produces the product. In terms of our plant performance division, everything from vibration condition monitoring to AI based at an asset level, as well as at a process level. And some of our customers go anywhere from gold mining in Saudi Arabia to power generation in Texas. Today I'm going to talk to you about how to scale AI in manufacturing, and basically I've come up with 5 points which I'll take you through. You can read them now, but I'm going to take you through each one during this presentation. John Dyke will be maybe a little bit surprised to see his photo here. John and I were at the Maximo World Conference, and if you've heard John speak, the biggest issue in manufacturing is there's many languages in many departments in terms of systems, and how do these languages speak to each other? And our digital manufacturing division is all about that. You know, you can't rip and replace all of these systems. You got to be able to gracefully and quickly connect them together from level 1 to the machines to all the way to level 4 to the ERP systems. And that's exactly what we do in providing an elegant platform which provides a very low code and quick way to connect things together. And if you're, for instance, a specialty chemical company doing batch records, the ability to pull all the data that goes all the way from the machine to the ERP system to produce the batch record, that's what our customers do. Now, in terms of AI, of course, AI provides trends and anomalies, and I always say that blue is good and red is bad. But really, what is the sequence of events that cause this anomalous behavior to happen? So what you have to do is not just use AI. AI is interesting, but insufficient. So this is the AI part of the process. But how do you put your domain expertise and your know-how? And what we do is we do that with connectivity of AI to failure modes effects analysis, which I'll show in a few slides. So in terms of our domain explainers, what we do is train these AI models on normal operating condition and normal operating behavior, look for anomalous conditions outside of normal, but that's really when the work starts. And we basically use our failure modes effects analysis, a severity scoring scheme, which basically connects and correlates temperatures and RPM, etc., to what is the highest contributing factors and what's the severity score. And based upon the severity score, what should you do today? And so this is prediction, and of course here on the right side is prescription. And it's really the same with processes, not just at an asset level in the previous slide, but processes also, that once you get past the FMEAs, it goes into the process optimizer, which provides plant level control or process level control, and in a real-time or near real-time advisory makes an adjustment so that you can stay within the golden batch. The other thing that is really how to scale AI is go from building these AI models, which I call a nightmare. It's, really difficult when you have to have SMEs and data scientists and services people and go through all these steps. And basically new technologies, including the technology that we've brought to market, allow you to have one person, typically a process engineer in a plant, become a so-called citizen data scientist that really almost in a templatized, wizardized approach to easily and efficiently build and deploy models. The other very important thing for scaling AI is really moving from a univariate world where you're doing statistical process control, you're really looking at one parameter at a time and making sure these parameters stay within a statistical band, to a multivariate approach. Because with SPC, what you're not really getting is the interaction between the parameters, so you can find really drifts and things that are actually happening that may actually be hidden because things are fine in a statistical band. And so going to a multivariate analysis allows you to take in many, many parameters and ingest these things, run them through the model, they look for interaction, and then why is this happening and what should I do about it in terms of corrective action, and to do it in a real-time manner. So AI has been said by Gartner Group that just really been relegated in a factory to predictive maintenance, to asset performance management, and certainly that's the case. That we have customers that we can spot catastrophic failure in a ball mill 19 days in advance. But we're also putting it into process optimizers where instead of just running the set points on a delta V controller and changing them from time to time, pulling data from the historian, we build optimizers on top of this environment. And in this case, this happened to be a gold mining company. Instead of changing their set points on a controller every 21 days, we were giving them optimizer suggestions every 30 minutes. And although they weren't changing the set points every 30 minutes, a more frequent change in set points, this between the gold band here and the green, that's money. They were able to squeeze a lot more throughput out and about a 1.5% increase in productivity. On a gold mine, that's about $4 million a year. So let's look at our world in terms of discrete manufacturing. This is a manufacturer of suspension systems for electronic components, and they had a large army of people doing final inspection and, in fact, rejecting more than they should have. So very high cost, and anytime defects happen, it's really an after the fact as to remediation. The challenge that they have is in terms of defects, there's a really wide range of defects in terms of frequency and intensity of these defects, and how do you categorize them? We built autoencoders. You can see here the mask is really what the defects are, but this is when the work actually starts in terms of these defects. What's the cause of the defects, and what action should I take on the line, automated now? And so the process is a little bit detailed in terms of computer science code, in terms of all of the autoencoders and CNN-based networks and optimizers. But basically what it allows for is, as the system is scanning and finding all of the defects, the optimizer is actually controlling the system. As an example, maybe slow down the RPM on the line. And then always this image grooming is an iterative process to, in fact, keep it within the parameters of the golden batch. So in summary, AI, it's been long in coming in manufacturing. There's no question about it. I think from prediction in terms of asset health to real time in terms of controls on the assembly line floor is absolutely a now. And then although AI is interesting, it's just an enabler, and putting, as Jim Davis would say, domain expertise into your AI model is critical. I'd like to thank you very much for your attention.